Okay, I'm gonna start recording. Anyone on Zoom, uh, shout out on your mic if you have questions. But that should be good. Okay, so today, the file I gave you is called surface textures, and that's what we're basically going to be doing. We're going to be creating a surface and then mapping textures to that with a curve, a tractor curve that tells you where the texture is going to be. So this is an example, the surface up there of what we'll be doing. And depending how much time we have, we can take the workflow from that 2D surface, 2.5D surface, and use it on a 3D surface, such as this arm. So all of these inputs are in your file, but we'll just be starting with the top two, which should be the surface and the curve. And we had them to start with, but I might redefine them as well, just so we can see how I got to that part.
Are we supposed to have all those blocks?
No, you're only supposed to have, yeah, let me pull them up. Just like 4 buttons on the left-hand side. So. Should I pick up an unknown phone call?
Yes.
Yeah.
Yes.
Okay. Well. Yeah, it's a robot. It was really convincing though, until I didn't say anything and she was like, okay, and I don't feel bad hanging up. Okay, so this is the file that you have. We'll be working with these top 2 components of the surface and the curve. Is anyone familiar enough with Rhino to be able to draw a surface? Does anyone not know how to make a surface in Rhino? Yeah, okay, good. So we'll remake it. We can also turn off this arm if it's in your way. We can select that component and preview it off, just so we don't see that, because we don't need it yet. So as you saw in the example, we have a surface and we'll be mapping a pattern on to that surface. We're going to use like a 3D surface instead of just a 2D rectangle, so we can see a little bit more how all the data is flowing. And it's somewhat easy to move points up on the z-axis, but it's a lot more difficult to move points along the normal of a surface. So I'll show you how to do all that with something slightly more complex. So to start off, there's a few ways to make a surface. We do have a tab in Rhino that has a lot of different ways to make a surface. The way I'm going to do it is by lofting 2 curves together, and that'll give us a really simple surface that we can start with. We can kind of see an example of what I'll be doing if we turn on this surface. Let me turn that one off. So does anyone know basically how to make a loft?
A loft?
Yeah, loft.
I have no idea what that is.
Nice. Avery.
Above
Yeah.
a space.
Okay. Someone else.
Yeah, you just need at the very least 2 curves.
Yeah. And we'll be like bridging between them with the surface. So that'll be our like 2.5D icon. So just to show, the loft command is in this surface tab. It's the 4th button over, but we'll get to that once we make the curves that make up the loft. So to start with the curves, we can use any of the curve tools up in the curve section. But as I'll say, anytime I use the curve tools, I like the second one a lot more because it follows the points pretty well. So I'm going to use that one. When we start drawing, it's going to draw on the XY plane. So it's going to be flat to begin with. So we'll just have to work with that. So I want to draw 2 curves that are relatively the same length, but they go in different directions. If we use 2 of the same curves, we'll still get a surface, but we'll make it a little bit more interesting with 2 separate curves. So with the curve tool, if you left click, it'll set down a point, and we can set down as many points as we want to get a more complex surface. I'm going to use 4 points for this curve and just hit enter. We got 1 curve. I used the second option. in the curve tool so that it has this little drop down button. You can use the first one. It'll just be a lot smoother, like between the points, whereas the second one actually follows the points you set. So it's a little bit, makes a little bit more sense. So to draw the second curve, this is crazy, but we'll do the same thing, just slightly different. So, and for this too, it's good to think about how many control points you're using. It's not going to matter an insane amount, but to make things easier for ourselves today, if I use 4 control points for the first curve, I'm going to use another 4 points for the second curve. I'll just make the second curve a very different shape. So as we know from class last week, once we draw a curve, we can edit the control points. So if we click back on the curve, it'll show some handles that we can use to move the curves around. So if you're not completely happy with the curve, feel free to move it, up to you. It's not gonna matter too much though. It will be good in some ways to keep the curves flat on the XY plane. So if you start moving them up in the Z direction, things get a little weird. So let's just not do that for now. But it would probably still work if you did that. Okay. So everyone's got 2 curves down.
Do they have to be the same?
No, make them different. It's just going to be cleaner if you click the same number of times.
Okay.
So if you did 5 on the first one, do 5 on the second. And it's also good to start and end the same way. So if you start on the left side of the screen for the second curve, if you also start on the left side and go to the right, that's a little bit nicer too.
Could be the same sizes.
They don't really have to. You can be close. Yeah, it's not going to matter too much. Okay, so once we have the curves, if we lofted these 2 together, it would work, but we'd still have a flat surface. So now that we model these curves on the XY plane, we're just going to rotate them 90 degrees up. So now we have like 2 surfaces that we can loft an interesting shape in between. So clicking on the curves, we have the gumballs again, and we can use the rotation tools to flip them up on their side. I'm just going to go 90 degrees. So if you remember from the other times we've used the gumball, you can grab the rotation tool and just hold down shift to lock a 90-degree increment. I'm just going to go for 90. So now they're just up on their side instead of laying flat. I'm just going to do that for both of them, but you can see the difference here. Okay, so we got the 2 curves up now. Now we can actually do a loft. And I'm going to do this loft in Rhino so we can use those tools. Is there a question on Zoom? Cool. So with them up on their sides, we can space them out however far we want, or you can keep them really close together. But we'll see a better pattern the more like surface area we have to work with. But up to you how far across you want to put them. But if you can imagine, we'll now drape a surface in between these 2 curves. And you could add 3 curves, 4 curves if you wanted to, make it a little more complex. But for today, I'm just going to keep mine at 2. Okay, so once we got the 2 curves, we can go ahead and loft it. So as I showed earlier, we do have the loft command in here. You can start with having both curves selected, or you could have starting with nothing selected, and it'll prompt you through what to do. So I'm going to go unselected. And with the loft tool, we can see it's now asking for the first curve. Once I select that, it's going to ask for the second curve. So I can hit first one, hit enter. And that's not the way to do it. So you need to select all the curves to loft. So you can select both and then hit enter when you're done selecting all your curves. And very similar to last week as well, if you have more than two curves, it's going to be important that you select them in an order that makes sense. So you're not skipping from front to back. It'd be good to go down the line sequentially. So once you're good, we can hit enter. And it'll come up with this. I wonder if I drew mine backwards. Maybe. Let me try this again real quick. Cool. I don't know what happened, but now it looks smooth. Does anyone's not look smooth like this? Yeah, what's it look like? It's like crossing itself. Yeah. Yeah, so
Can
if
you
you,
put it in shaded?
yeah, I can put it in shaded. If you select one of the curves and just flip it like around the z-axis 180, that should fix it.
Mine just twisted more.
Yeah, for some reason mine was flipped when I selected them in the loft command, but when I selected them first and then did the loft, it was fine. But I can show what it looks like if it is different than this. Looks pretty chill. Nice. Okay, so if one of these curves was the other direction, let me try it now. We'll see what happens.
Avery had a good point.
Yeah.
When you click the curve for the loft,
Yeah.
you click on the same end of each line, it is nicer.
Yeah, no, that is a good tip. And I was trying to see as well, when you do the loft command, I don't know why it's going straight to this, but I don't know. When I showed my first year class this, usually it comes up with a little arrow. Then you can like change the direction, but that might be for more than two curves. So Baldanaise. Yeah. Oh. Actually, mine might have an update. There's a new button that you can hit in the loft options to align the curves afterwards. So maybe that's why I'm seeing something different. But I have not seen this align curve button before. So but I digress. If it's not working for you, the surface is in Grasshopper, so we could just go with that one. And it'll be fine.
How come we're making the surface in Rhino instead of Grasshopper?
We could make it in Grasshopper. It'll just take a little bit longer to draw the curve and then, but it would work.
Okay.
Yeah. Mohammed, we have not assigned anything to Grasshopper yet, but there is a starting file in Discord, in the shared files section, and you can just grab that one from today, and we're just starting with that.
Yeah. I think you need to do them individually. Because you have them
Okay, so we're gonna keep going with the surface. Again, if your surface isn't working, we do have this one that came in with Grasshopper. Cool. So we could use either. I don't know what I clicked. Or we could use a new one, up to you. But okay, we have the surface now. And I gave you a curve as well in the file, but if you want a different curve, feel free to draw your own curve. Basically what we just did, except don't loft the curve or make a second one. But we're going to use this curve as the attractor. So any of the textures on the surface that are close to this curve are going to be more prominent than ones that are farther away, is basically what this curve is going to control in the future.
So do we draw the curve onto the surface?
Yeah, if you want to draw another curve, you can have that one overlaid on top of the surface, or if you just want to use the ones that I gave you in here, these will work. But yeah.
Does it matter that yours is like transparent, but ours is?
Yeah, yours is the solid. So yeah, I'll touch on that. If you are putting in the surface that you made, let me see. We'll have to get another surface component. Not again. Okay. So you can replace the surface icon in here. And I'd recommend that because I already reparameterized this one. It has that little icon to the left. Or you can grab a new one, but when you set the surface to the icon that I gave you, it'll show up like red, but then also have the silver of the object under it. One thing you can do is we can set the surface to be on a separate layer and then just hide that layer because we're not going to need it again. So in Rhino on the right side, you might have to make Grasshopper a little bit smaller, but it should have a layer panel over there. So let me know if we can find that. Yeah, we'll just set the surface onto the surface component that's in there. You don't know why you don't have that right panel, but no, right next, yeah. But you should, if you go under panels at the top, at the very top toolbar of Rhino, there should be a panels button. You can just turn on layers. Yeah. So
I don't know. Sorry. You're good. That's good.
okay, you have a slightly smaller window to work in now, but it's fine. It's just always on the side, but you can also, so it says layers and then it has two lines next to the word layers. You can just grab those two lines with the mouse will change and you can like drag it to a different section and like dock it on the right side if you really want to.
Yeah.
Yeah, I think but it's fine. Oh, there you go. Yeah, if you drag it all the way to the right, a little blue box should come up. You can also leave it floating. It is fine floating. Okay, so if you don't have any layers, you can hit this little new page icon to add like a new layer. Yeah, and then if you select your surface in Rhino, then you can right click on the layer you just made and then hit change object layer at the bottom of that big drop down list. And then once you do that, you can hit the little light bulb icon and the surface will go away in Rhino. So now we just have the Grasshopper preview, which is nice. Yeah.
You said don't use the one that you left in?
No, use the one that I left in because it has the reparameterize. I just grabbed the second one just to show. But
I opened that file, but I don't have the one you need. It's not preview. You have to go.
Yeah.
Wait, my screen.
Yeah, you got to select the little component. So just select that. Yeah, there you go. Cool. Okay. So we've got the surface and we got the curve, and it's important that the surface is reparameterized, which it should be if you put your surface in the component that I gave you. Okay. At this point, we can put a pattern on the surface, and this is very, very easy now that we have Lunchbox. So if you pull up the Lunchbox tab, the Lunchbox tab has this one section called panels. And if you drop that down, there's a lot of different options for different kind of cells that we can put on a surface. And it has to be a surface. That's the important part. It can't be a mesh face or something. It has to be a surface. So we have a lot of options here. We're going to use the diamond panels today, just for this workflow. If you use anything else, it's probably not going to work correctly. So we'll go diamond. So with this diamond component, it's got three inputs, surface, U, and then V. Surface probably makes sense. We can plug our surface in. Once we do that, it'll automatically populate the surface with a bunch of diamonds, which is cool. Did everyone get stuff on the surface? Nice.
The layer.
Okay, so there's two other inputs here, U and V, and this is going to control how many diamond panels we have on this surface. Currently, it's 10 by 10, I believe, yeah. So across lengthwise, it's 10, and then across widthwise, there's also 10. But we can change both of those numbers. So we'll do that with a slider, because it's easy to update in the future. and say we could start at 10 and maybe go up to 30. And this will just allow us to select different numbers of panels going the U direction and the V direction. So if we use 2 of those sliders, we can use one of them for U and the other one for V. Thank you. What was that? Oh, it can be whatever you want, but just note that the number is going to control how many diamonds you see going across. So 1 is not going to be that useful. But anything like above 5 will actually start to get some detail. Okay, so as I change these sliders, we'll see the number of diamonds will get more dense in one way and then the other. The numbers you put are up to you. We can come back at the end as well and change these if we want to see slightly different patterns. Yeah. Yeah, so it takes the surface, say, is however big you made it. But in order to map stuff onto the surface in like an understandable way, reparameterizing it is basically taking, so my 2 edges are different lengths, but if we reparameterize it, then the bottom length is going to be set to 0 and 1, and the side length is also going to be 0 and 1.
So you can always reparameterize your surface when putting it into a different camera.
Sometimes it's helpful. Like if you want to, in the Voronoi tutorial we did on like one of the first classes, when we used that multi-dimensional slider to set a point, the surface was like 100 millimeters long, and the MD slider only goes from 0 to 1, so the point was barely moving. But once we reparameterized it, the point would go from the bottom left all the way to the top right, even though the rectangle is a lot bigger than what the MD slider could do. So yeah, it's nice. But you don't always need it. It's just for like if you're mapping things onto a surface, it's nice. Yeah.
Are those just number sliders?
Yeah. Yeah. Yeah, so you can set these to be whatever numbers you want. Okay, so first thing we'll do, if you notice the surface that we generated is not technically on the surface that we made, it's a little bit lower like polygon count, so it's faceted off that surface, and you can see it a lot in these arches of the shape. So the first thing we'll do is actually, in order to control how the pattern is going to be offset from the surface, what we'll be doing, basically right now we have the diamond shape, so basically a square. We can take that center point like in the middle of every single diamond and move that up basically away from it. So then if we remake our square into a pyramid, then we can get something that is more 3-dimensional that comes off the surface. So we will, yeah, we'll have to figure out the normals from the surface, which is where this next part comes in. So knowing that, we'll need to find the center of all of these diamonds, and then we can use the center with the normals of the surface to move it away. So in order to do that, we can use this component called surface closest point. And I think I misspelled it. Yeah, so this bottom one, surface closest points. And what this will do is it'll take a point and a surface, and then with those two, it'll find what point from your original point is closest on the surface. So it'll be a very small change, but something that is quite important. So we have the surface that we can plug in, but we'll have to get this center point from the diamond. The easiest way to find a center point of most things in Grasshopper, would anyone fancy a guess at what center point? No, so it's called area. So get that in your head. It's used a lot.
Got it.
For some reason. But if you have like any shape, any bounding box, you can always use area and it'll give you the center point of that shape. So a little bit of a question there. I did set him up for failure. That's exactly what I did.
That's so good. I found it. I pulled the trail.
Yeah. Huh? You found it?
I got all like.
Nice. Yeah. So there's one input here. So if we plug in any kind of geometry, it'll automatically give us the points in the center of that piece of geometry. So since I have 231 diamonds, it's going to give me 231 center points, which is pretty nice. The area component does also give you the area of the geometry, but as far as I've been using Grasshopper, that's always been useless to me. So, okay, so now that we have these center points, we should have them. We can use these. So coming out of C for center, we can plug that into P for the surface closest point. And the points are not going to move much, but we'll see they are now mapped actually onto the surface. So this component's nice because on top of giving us the point that's on the surface exactly, it's also giving us a little bit more data, which is slightly more important. So the UV coordinates of that point on the surface, so like the XY value of where that point is in relation to this reparameterized surface is going to be quite helpful in the future because we can take the surface and find the normals, but we need to find what UV value we want for the normals. So it's basically like XY if you think about a flat plane. But in digital software, a lot of the time especially if you're doing like texture mapping, for like CG or something, they use UV a lot. It's just a way to think about like a surface that isn't flat in two separate coordinate systems. So it's not XY because we're going up and down in the valleys, but
It's like if X was curvy,
right,
going along that curve.
Yeah,
Okay.
basically, yeah. Like if I was to look at this surface top down, then it gets back to a rectangle, and we can see like the XY value of this first one is going to be some like 0.1, 0.1. So the UV is probably like that too.
But if you looked at it from the side,
Yeah, then it gets different. But we don't worry about the Z dimension because the surface doesn't have any Z dimension to it.
it's not.
Right. Well, I mean, it is kind of.
Kind of like projected XY coordinates.
Yeah, like it's not XY, but basically it is. It's just on a surface. So you could call it XY, just know that if you go in the X direction, the point might be below you or above you, just on the surface of that
Oh.
surface.
Okay.
Yeah. Yeah.
So you're just saying, it's just X, Y, but it's the plane, but you're just ignoring Z.
Basically, yeah.
Okay.
Because the surface itself doesn't have any Z dimension to it, but it does move up and down in Z, but there's no like thickness to the surface. So we don't need all X, Y, and Z. Yeah, okay, so now that we have this, we can start with our attractor curve tiny little algorithm. So the first thing to do, we have the curve. If you redrew it and set it in this component, cool. If you're using the inputs I gave you, it's already in position. But it doesn't really matter what curve you drew as long as it goes over the surface at some point. That's all that really cares about. So with this curve, we've just found the closest point on a surface, but we'll also want to use a component called a curve closest point, which will find the closest point on a curve. So I'll grab that component and we'll see what it does. Okay, so this component right here, curve closest point. So with this component, it's got two inputs, a point and a curve, which makes sense. And then on the output here, we also get the point on the curve. We get the parameter of the curve. So if we needed to find like tangent vector on that curve at that point, we could do it. But the important one for us today is going to be the distance. So how far is each point away from the curve that we set? And this will be important because we can use this distance as a way to control the fall off of our texture on the surface. So it's only really textured around the curve, and then it gets slowly back to the actual surface the farther you get. So with this, we can use the point from surface closest point as the point value to measure from. And then the curve that we can control in Rhino, we'll use that as the attractor curve, so that can go into C for curve closest point. When you do that, we'll see the points being projected onto this curve. But the points don't really concern us today. All we really care about is the distance between the start point and this new point that we just found.
Can I ask a question
Yeah.
that is kind of unrelated? What does it mean when, the boxes are orange?
If it's orange, there's technically an error,
Okay,
but it's maybe not bad.
it's basically like, yellow stuff like that.
Sure, yeah. If it's red, there's an error,
Yeah.
but sometimes it's not bad.
Okay.
So it makes a lot of sense. I don't think that exists, but you know. But if it is either orange or red, there will be a little bubble up in the top left and you can see what the error is. So if you need to address it, you can see what it's thinking about.
Usually the red one doesn't happen anything. You know that it's wrong because nothing happens.
Yeah, yeah.
Have you had it so that the closest other side of the
I have a different plugin that just reads that out for you. Yeah, to have both at the same time. It's called bifocals if you want to download it. It's a very small component that all it does is turn on the names. Okay, so now that we've found the closest point on the curve, we have that distance value. What we can do is set up an operation that says, if the curve is farther than this distance away, we can just set that value to be 0. So that's what we'll do basically right now. There's a couple ways to do that. 2 ways that we're not going to use today. We could use a smaller than or a larger than component, and that'll say if the distance is smaller than whatever number we want, don't look at it. Or if it's larger, same thing. But one that can do both smaller and larger is going to be a component called includes. So we can set up a domain, so a lower bound and an upper bound, and we can say any points within this range we want. So we'll see how powerful this is later once we have more things set up. So with the includes component, again, we're looking at the distance between the points, so we can use that as the value that we're going to judge by the number that we want to set. So the number that we set is going to be the range around the curve that will actually affect the pattern that we want to put on there. So the other input for includes is the domain to test with. By default, it's 0 to 1, but that's probably not going to be useful for us. So in order to construct a new domain, we can use a component called construct domain. Just this green one from 0 to 1. So construct domain, we can put a lower bound slider and an upper bound slider, and then we can get like a range of values. So we'll use that. And with this, I'll add 2 sliders to A and B, just like we've added sliders before. If you made your surface like really, really big, you might want a larger slider, but you can figure that out. When you do it, I'm just going to do 0 to 10. Should be enough for the small surface that I have here. And that was not 0 to 10. So we need 2 sliders for the domain for A and B. So if you created one, we can probably just copy and paste to get the second one. The one going into A is usually always going to be smaller than the one going into B, but I'll plug both of these in. So the range. Oh, it was 0 to 10 when I put it in, yeah. So if you can imagine, if I were to start the domain at 0 and end the domain at 7, any point within 0 to 7 is going to be within our selection set. Everything else will fall outside of that. Maybe if I did a domain from 3 to 7, all the points from 0 to 3 will be left out, but the points from 3 to 7 will be in the group, and everything above 7 will be left out. So we have the smaller than and the larger than control kind of at the same time. So once we set up the domain, we can plug that into the domain input for the includes value. So we can see coming out of this one, we have a list of a lot of true and false values. Basically, if the point met our argument 0 to 7, then it gets a true state. If it did not meet either of those, it gets a false. And we can start using these true false values to actually select points. The first thing to do though is to actually get the index. So if we had a panel, which you don't need a panel, but we need to find where all the true values are, and then we can say, we know the points are in the same order as this true false list. So any true point, any true list, we know we want that point. So we'll just need to find those index values of true. One way we can do that is with this component called member index. So member index is going to give us the index of some input. In this case, we'll be grabbing all the false values to throw them away. So I'll use this component, member index. So we've got two inputs, the set to do the search on, and then the actual member that you want to search for. So if I want to pull out all the false values, we can plug in false as the member to find. Easiest way to do that is with a Boolean toggle. So you can type in toggle and it should come up. And we've used this one in the past, but we can set this one basically to false and that'll work. And that'll just go into the member to search for. So we'll find the index for all of the false values in this list. So we can use the true false list from the includes component as the set that we're searching. So plug that into S. And now if we hover over the output of the index, we can see that 9, 10, 20, 21 are all of the false values. So we have that list. So what we can do is, we don't want to get rid of this distance list because these distance values are still important. The closer it is, the more we want to affect that texture. But we know that anything outside of our boundaries, we would just want to set to 0 so it doesn't move at all. So we can do that basically taking this list of distance values and saying for every false indice, we're just going to set that number to 0. So we take away 2.9 to set that to 0 if that was false. So the way to do that is we can work with the list. And there's a lot of components in set that can do that. We have all these list items here. But for this specific thing, we'll be using replace items. So we can take all of the items from the distance value and then replace them with a 0 value at the index values that we found from false. So we'll see what happens here with that. So there's a couple inputs here. I only care about the top 3. The weighted value at the bottom isn't going to matter too much, but first one is the list to modify. So we know we want to take the original list and set all of any of the points that are too far away just to 0. So we know we want to affect this list, so we can plug that into the list to do the operation on. And then we know we want all of the values that are too far away to just be set to 0 so we don't move them. So you could use a slider, or a better workflow is just to use a panel because we're never going to change this number, so we don't want to have that option. We'll just grab a panel for 0. So 0 is going to be the number we change those values to. So if you look at the second input, this is the items to replace with. So we want to replace numbers with 0, so we can plug that in there. So the last one on this is the index to do the replacement. So we know we have the indexes from all the points that are too far away. So we know at 9, 10, 20, and 21, we want to replace the distance values with 0 so they don't move at all. So we can plug that index list into the index input. And then when we do that, we can look at the list coming out on the other side. And at those positions, so 9, 10, and 20 are now all 0. So now everything too far away is not going to move at all.
So that is the distance between the line and the surface.
Yeah, so the curve is playing like 2 separate roles here. The first one is all the points that are like super close to the curve, like say these points around that position, those are going to be affected a lot because they're pretty close. As we move farther away, the distance is going to get greater. So we can kind of flip it. So anything farther will get a lower number, anything closer will get a higher number. So that's the first role it's playing. So if we didn't have this includes, we would just have every single diamond being affected. But since we have the include, we're saying we're going to fall off, but at some point we're just going to set them to 0. So we're going to have the original surface again. So they don't move at all. So in that way, it's kind of playing 2 things here. 1, with the domain of the distance, and then 2, the distance from the point to the curve is also going to affect how much it rises up. So we'll see, yeah, we'll see how that happens once we get to that point. But I can show real quick, again, back to this one. We can see that curve kind of manifested in the pattern. And as we get farther away, there's just
Oh, I
nothing.
did not see this.
Oh, okay,
Okay,
okay.
this makes
Yeah,
it
yeah,
much more
yeah,
sense.
yeah. This is what we'll be getting to.
Okay.
Yeah. Okay, so just to compare the lists, the one before had all the distance values, the one after, all those numbers larger than 7 have been set to 0.
Not that I've ever heard of it.
Okay, so at this point, now we want to control the fall off of the pattern. So we don't just get like a hard cliff edge and then have nothing. We want to have it smoothly go down to 0. So we have this new list that has some zeros in it, which is a good start. And now what we want to do is take the distance values in here and remap them. So we're going to take the current numbers and set them to a different range of values. We're doing this because right now, the points that are farthest away, so say a point is 5 millimeters away, if we just use that number as the offset value, it's going to move by 5 millimeters up. And then any point that's right on top of the curve, so say it's like 0.1 millimeters away, is only going to move up 0.1 millimeters. So if we did that, the pattern would kind of be backwards. We'd have nothing at the curve and more at the edges. We want the opposite of that. So we'll take the current set of numbers and kind of flip that around. So anything closest is going to be affected more. So we'll do that with a remap numbers component. We might have used this one before. I can't remember, but basically it takes a set of values. It takes the domain that set is in, and then it'll take a new domain to redo those values to the new range that we want. So we'll walk through that. The first thing, we know we have distance values that we need to change the numbers of. So we have those from replace. So we can just plug those in to the value input because we know we want to affect these numbers. So that's easy enough. The second one is we need to find the domain that all of those numbers exist in. So if we had 0.1, 0.2, 0.3 as a list, then the range would be from 0.1 to 0.3. That's easy when it's only 3 numbers, but when it's 231 numbers, it's going to be really hard to, by eye, figure out what domain that sits in. But there's a component that does this for us called bounds. And bounds, it has one input and one output. We can plug in any list and it's going to show us what domain that list sits in. So what's the lowest number and what's the highest number? So we can use that and just run the same list of values through that. And then we can see, at least for me, I have a domain of 0 to 6.88. It might be different for you, but the 0 should always be the lowest because we did just set some numbers to 0. So now that we have this domain, and again, for reparameterize, this is kind of the same thing as reparameterization. We have one set of numbers and we're just putting it in a new range. So we have that original set 0 to 6.88. We can use that as the source domain. So where we start from. So we'll have to define a target as well at this point. Right now, by default, it is 0 to 1. So our list is already remapped. So basically, if we took the number 6.88, now that we've remapped it to 0 to 1 as a domain, 6.88 would now change to 1. 6 would probably be like 0.9 or something, and then down. So we'll have to set the target because we don't really want 0 to 1 right now. So same thing we did with the includes. We're just going to set up another domain that we can put numbers in. So same thing as before. We'll use construct domain and then set to number sliders for A and B. You can put whatever numbers you want in here. You could go negative if you want, it's not gonna matter. The important thing though is different from the first domain we did where we started with a low number and then B was the higher number. In this sense, since we want the points farthest away to be affected the least, we'll want, all the small numbers to be bigger and the shorter numbers, whatever, opposite. So basically the first slider A is going to be larger than the B slider. So I'm going to set the B slider to 0. And this will now control the fall off from, if this was, say, a cross section of that center curve, we'll want this domain start. So any point closest to be higher up, and then the points farther away to be lower down. So we should get this nice curved fall off from 0 to the highest back to 0. So with that, we can plug that into the target domain. And now we should have a pretty good set of numbers. One thing to note, if we look back at this list, if you remember from earlier when we set those numbers to 0, we set 9, 10, 20 to 0. But now we took the lowest number and made that the highest number, which in this sense, all the zeros got set to 2, which isn't ideal because we don't want them to move at all. So one thing we can do is just replace it again and just throw them back to 0. So we can duplicate this replace component and drag it over to the right side. We could create it from scratch, but it's not going to be worth it just because we want all the same inputs coming in. So I'm just duplicating the replace and the 0, moving it to the right side. And then we can just change the input for the list from what it was previously to our new list. And that'll take those values that went up to 2 and set them back to 0. So I just copied these two, so the replace and the 0, and then just moved it all the way to the right. So if you like Control C, Control V, another one should pop up, and you can just drag that over to the right side. Yeah, so once you drag them over, we just want to replace that first input with our new list of values. So we'll only be changing this first input from what it was before to now this new remap, so we can plug that in.
How do you unmake connections?
Yeah, so I mean, easiest thing, you could just drag a new input into it and it'll kick out whatever was there before. Which if you're just replacing the first input should be all you need to do. Yeah. Okay, so now we have the remap list and we have those faraway points set to 0. So now at this point, we can actually find the normal value from the surface and then use that to start moving these points based on the values we just defined. So these are going to be the movement values. We have those. The lowercase I is just this index, the member index from before. Yeah. Because we know we still want the same numbers to be 0, so we need that same index to still set those things back to 0. Okay, if that's working, the next thing to do is actually find the normal vector from the surface and then use that along with the movement numbers that we just found to start moving these points. So to do that, we can use this evaluate surface component. So this little hemisphere with a point coming off of it. And evaluate surface has 2 inputs. It has a surface and then it has UV inputs. So we have the UVs from earlier, and clearly we have the surface from the very beginning. So this will come back in a second to those other values we just found. Yeah, working. Cool. So we have the S input, the surface input, and we have the UV input. So we have the surface from the beginning. So we'll use that same one. So I zoomed out a lot, but I'm going to drag the original surface input all the way over to the S on evaluate surface. Step one. Second one is to use the UV values from the surface closest point as the UV values to start evaluating the surface at.
What is this UV point again? That's the.
So the surface closest point from the beginning of the workflow, it had the point output, but it also has a UV capital P output.
I'm scared.
It is
Oh.
kind of spooky.
Yeah, it's gonna put a bunch of big planes everywhere.
Yeah.
So,
Are those the planes of the UV point?
yep. So all of these planes, you can see them are kind of aligned to the surface.
Why have so many?
Yeah. It's gonna have one plane for every point, and since our surfaces are usually pretty small, that plane overlay never changes size. So a small surface is gonna have a lot of big planes on it.
Yeah.
Yeah, but there's a lot of outputs coming from this. We have clearly the point at UV, which we knew that. Yeah, graph everything, that'd be great. We have the normals as well, which we'll use. But other things, we have the UV directions. So, okay, this gets a little more complex. We have the U and the V.
Yeah.
But at that single point, we also have an X and a Y, like going different directions from that single point.
Okay.
So that's what these U and V values are. And then the last one is the frame. So this is what's actually showing the planes on there. So the frame has an origin point and then a Z, so basically the normal vector. So it's a plane with a direction.
Is the plane normal to the surface?
Yeah. So some of these values at output are kind of redundant. Like we have the normals and we have the planes. I guess more data is good, but we'll just use the normals for this one. Okay, so what we can do is with any vector, like with the normal vector, it has a generic distance, probably 0 to 1, which is nice, but it's not what we want. We have the direction we want to move the point, so the direction off the surface that we want to move. But this doesn't give us the distance we want to move that point. So the numbers we found earlier are going to be those distances that we move off of the surface. So when working with vectors, there's one nice important component called amplitude, which will set the distance for the direction. So we have the normal direction, but we want to actually set the distance value that we move those points at. So we'll grab amplitude, and it has those two inputs. So the first one is the vector, second one is going to be the amplitude or the distance to set that vector to be. So we can use the normal values as the vector. And then we can use our numbers from the replace from a few minutes ago as the amplitude. So as that distance. And I'm just going to hide everything we don't need because we won't be able to see what we're doing with all those planes in our way.
Where did you stop that? For
Uh,
like hiding?
You can go back however far you want, but you can stop just like at the area or something. Yeah. Just get those planes to go away basically because they're going to take up most of our field of view. Okay, so at this point we have everything we need to start moving these center points away from the surface. If you remember from the shortest walk tutorial where we moved those curves off the body, basically the same thing, just with surfaces this time. Okay, so we have the points from that area component at the beginning that gave us the center points. And we know we want to create a pyramid, so we need to move that center point up so then we can create that pyramid shape with the fifth point. So we have the points and we have the vector to move it. We just need to move it. So redemption round, what component you think moves a point? Yeah, it's just move. A little bit simpler this time. So yeah, we can use this move component with a little orange arrow. And this component, it has two inputs, one for geometry and one for the translation. Geometry could be anything. We can move anything with this. In our case, we're moving a point. So we can use those center points and route those into geometry. And by default, the translation vector is just going to be Z10 or Z1 or something. So all the points are automatically just going to move up into the air when you plug those in. So that's the first thing. So this is the most basic translation. Just everything has the same vector. Everything's going up. But we've already put the work in to get custom vectors for each point. So we can plug that vector from amplitude into translation. And we'll see the points actually moving in relation to the surface now. Looks like I've been upside down this whole time, but there we go.
Why are you doing this?
So before we move forward, we're like probably over halfway with this one at this point. But we can see pretty clearly the points moving as we change some of these domain sliders from earlier. So with the most recent domain we made, this was remapping all the distances to the height value. So if I were to change this value, we'll have the points getting farther and farther away from the surface as I move this slider up. So we can get them pretty far away from the surface or back to zero. Yeah, let me come look at it.
What's the error setting on the number two? So if you hover over geometry as the input, yeah, keep on the left. So it looks like you might have plugged area, like the area output into geometry.
Okay.
And we'll just want to grab the centroid output from area. Yeah. So yeah, if you grab that centroid output as a wire, and after you zoom out, it's
because you're.
yeah, then go over and then zoom in
Yeah,
that into geometry.
Oh, okay.
Yeah.
Okay, thank you.
Yeah.
Over here, yeah.
Yeah.
This, feels weird.
Um. All of them are zero. Oh, you know what it might be is it could be that this is the domain is deleting everything instead of just the ones that you want to look at. I think it was just too big. So yeah, now it yeah. So it looks like you made your surface a lot bigger than I made mine. So our slider value is different. So you might just want to turn up all your slider value a little bit bigger. Yeah. That's a good question. Sometimes this things are upside down. Just turn yourself upside down and then it's right side up. You know? Or if these are the actually those are the original ones. If you go to the second domain to the right a little bit, instead of 4, you can just set that to like -4 and they should go the other direction. Yeah, so I have to edit that slider just to go into the negative range.
Oh, this is.
I really don't need.
Wait a minute.
Like,
Is red wrong? Is it-
I mean,
Yeah, now they're going up. So it's just the way this like the way the surface is, that it's all pointing like down on the Z.
You're there.
Just a little finicky thing, but me, kind of like I think this.
Oh, wait,
I don't know.
Make it evident? No. So your first set of sliders, A has to be left,
But you could try turn down.
or your second set, A has to be bigger. Yeah, I think that.
And then, the range on the first one. It's working correctly, and we'll see once we get the pyramids and like the geometry of the dash.
It hasn't.
So we'll get to that.
Yeah.
Why is mine? Not
Yeah, so if you set any like that's a negative sign, it'll just go the other direction. Yeah.
Why would it do that? What's mine doing?
Well, yeah, question.
Why is it dark?
That is a good question. If you,
Oh, sorry, my mouse.
oh yeah, we can look at it over there. Yeah, something might just be in a little bit weird. Okay. Yeah, we can go look at it.
How are you making?
Oh, okay, so the input for this lowercase I should just be the same as the input for this lowercase I. We want to set those numbers back with 0, so we just need the same as this. Which actually looks like this one is set up correctly. So I'm just gonna replace this one with there. And then that should be good. And yeah, you can flow well. Yeah,
Okay, so yeah, now that we're at the step, some of them that are going down on the Z, it's just the way the surface is. So however way you made the surface, it's kind of hard to tell, but the surface at a single point, it has a positive normal vector and then a negative normal vector. So it might just be for some of the ones that were going down, your surface just thought like down was up in the way that the surface. Mine was also going down, so I just turned my camera over, so now it looks better. So yeah, because now my Z is pointing down, which whatever is fine. But you can also just set these values to be different, so I could go on the negative direction, and now it's going up. So cool. Okay, so now that we have the points moving, we can actually start constructing the pyramids. So let's see. Okay, first thing we're gonna do is deconstruct all of the diamonds to get the vertices out of them. So I basically want to find the vertices of all of these diamonds in here. So we can use to deconstruct to find the vertices, faces, or edges. You can do this for B-reps, meshes, a lot of different things. But if we do deconstruct B-rep, this will take any kind of B-rep geometry type and then find the vertices, edges, faces of it. So I'll probably say this a lot, but the data types are very particular in Grasshopper. So if you're working with a mesh, you can only plug that into things that want meshes. If you're working with a B-rep, like in this case, we have very simple Rhino B-rep geometry that works well with B-rep inputs. So basically, but for this one, we're going to want to input the same diamond shapes from earlier because we want to find the points that surround each one of these diamonds. So from the diamonds, we can grab the output of diamonds and plug that into the B-rep input over here. You might have to zoom out and zoom back in a little bit, but if you hold down the left click, you should be able to drag the wire all the way to the right side of the screen. So once you do that, all of the diamonds are going to light up green like this, and we can see like all of the different parts of these shapes.
What was it from?
It was from the original diamonds from the surface component.
Oh, okay.
Yeah. So with the it deconstructed, all we really care about is the vertices. Basically, we're going to create new faces, taking into account the fifth point that we just added. So we'll need the first 4 vertices to do that. To make the pyramid shape, we'll be using this component called Delaney mesh. What this is we can put in points and planes, and we can construct new mesh faces with the point and plane inputs. So we'll use this to construct these little pyramids on top of these diamond patterns. So we'll use that green one, Delaney mesh. And with this one, it needs, as I said, point inputs and plane inputs. We have technically all the points we need. We have the original 4 from the diamond, and then we also have the 5th that we moved away from the surface. But we need to combine those into the same list, so we know that we want to create a new pyramid out of 5 of each. So to do that, we have from the deconstruct VRF, we have the vertices, and we have the 4 vertices of each diamond on a separate list. So the easiest thing to do would just be to add the 5th point from the move component into each of these lists. So instead of 4 points per list, we'll have 5 points. So we'll take these points, put them in. Easiest way to do that, we did replace item earlier. We'll do insert item now. So instead of replacing a number, we'll be adding a number onto the list at the end. So we can use the insert for that. The insert works pretty much the same as replace. The only thing is we're not replacing, we're adding to, but everything else still tracks. So we need a list to modify. So we can modify this original list where every diamond has 4 points. So we can use that as the original list. We know we want to add our new points in to each one of those lists. And we get to play a little bit with the theory of lists and trees with the rest of this workflow. But you'll notice, or you should notice, that you have a dotted line coming out of vertices and into list. That is just denoting that if we hover over V, we see we have all of these lists that say 4 points, 4 points, 4 points inside, which is a grafted list is the terminology. If we hover over G for the translated geometry, we'll see that we can actually see every single point and its X, Y, and Z values. So this is telling us that all of these points are in one list. But in order to add, say, the first point to the first list and then the second point to the second list, we'll have to put all of these points also on their own grafted list. So we'll want these two to match up. So we have 0 to 230 lists. We'll want to see the same thing for these points. So it's good we have 231 because that'll fit in perfectly if we graft each one to its own list. So easiest way to do that is to right click on the G, that output, and we can just come down here and select graft as an option. That'll add a little icon onto the move component. So now if we hover over G, now we see lists with 1 point put in each list. So n equals 1 for 231 different lists. So now we have 231 lists from the top and then 231 lists from the bottom. So now everything is clean, similar, and nice. We can take the first point in the first list and put that with the 4 points in the first list. So we'll see what that does. So now that we have these grafted, we know we want to use these points to append into the original list. So as we know from before, the second input here is going to be the items to add into. So we can drag that wire over. You'll also notice the second wire is dotted again. So both of these we can see are grafted. And then last thing here is just to fill in the index for this last point. The way we're going to set up the Delaney mesh is the 4 points of the base diamond are going to be our first 4. And then we want this last higher point to be the 5th point. So in order to do that, we're going to have to place the 5th point in the 5th position. So does anyone know what the indice for the 5th position would be? Yeah, 4. So we can use a panel again. So 2 slashes, and we'll put in the index of 4, which will put our point in the 5th position. So we're starting at 0, so 0, 1, 2, 3, 4. And we can add that into the I for the indice. So once you do that, if we hover over the output of the insert list now, we'll see we still have 231 lists, but now each one has 5 points in it instead of 4. Okay, so now we should have everything we need to actually set up the Delaney mesh, and we'll start seeing these pyramids populating in Rhino. So first thing, we have all of the lists of 5 points, so we can use these in the point input. And this will get us little pyramids. It's pretty nice. One thing you might notice with some of them, we have an open face on it, which isn't desired, but we can fix that because we have a second input here with the Delaney mesh. So we're pretty close. The second input is the plane. So this is the base plane. Right now, it doesn't really know what the base of the shape is going to be. So some of them have a weird open face on the side. We want to make sure all of that, those open faces are all on the bottom. So pretty much as close to the original surface as possible. So we already have those planes. If you remember from Sean's exclamation about 15 minutes ago, we have all those hairy planes. Yeah, we have all of those. And we have them from the evaluate surface. So we have all of those base planes for each point. And again, when we touched on this, those planes are in the frame. So that's the plane. It's origin and then a Z vector. So we have these coming out. One thing you'll notice though, we have a dotted line coming into P, but if we hover over the frame, we see that these are not grafted. We have a different plane and they're all in the same list. So before we drag the wire, we can set this prematurely, but if we right click on the plane input, we can go ahead and graft this one, just knowing that we want to match the grafted points with a grafted set of planes. So we'll just add that to start. So now when we drag the frame in, again, it's not grafted in the evaluate surface, but once it hits this graft icon, the list will become grafted. So now we can see we have one plane in each separate list. So again, these are lining up. We have 231 lists, same with the planes, 231 lists. Now that open face should be moved to the bottom of every single pyramid. Okay, so before we make this into a nice mesh, we'll finish off with the triangles that we've forgotten about on the outer edge. So if you've noticed, not every shape is a diamond. There's also triangles, and they're both coming out of that original Lunchbox component. We've been working with the diamonds so far, but now we're just going to take a small look at the triangles and get those set as well. So we want to create the mesh faces, so the Delaney mesh faces, same thing we did with the diamonds, but now we want to do it with the triangles. So it'll be pretty much the same method, just a little bit simpler since we're not adding another point to it. But we will want to deconstruct the B-rep of those triangles so we can find their points and then use those points to construct the Delaney mesh. So same thing as before, deconstruct B-rep. Only this time we'll be using the triangle output from the Lunchbox component instead of the diamond output from earlier. No, you're good, you're good. So I took the triangle output from Lunchbox and then just dragged that all the way to the right side of the canvas and plugged it into a new deconstruct B-rep component. Yeah. And once you do that, we should be seeing the triangles light up green around this outer edge. So we have a lot of green triangles. Okay, so with these green triangles, again, we have the vertices, and this time we have 3. Does anyone know how many points a triangle has? Yeah, so we got 3 points, which makes sense. If we had the list with not 3 points, I would be worried. So we have 3 points. With this, we can construct a new mesh with these 3 points. So same thing as before, we'll use Delaney mesh, except this time we don't have to worry about the base plane because we're just constructing a 2D shape and not a 3D shape. So we have the vertices, we have Delaney mesh. We can plug the vertices into the points input. And now we have lots of tiny little mesh triangles around the outside.
Why didn't we have the graphs?
Yeah, we didn't have to graft any of these because we weren't adding any points in. And the deconstruct VREP automatically grafted it just because it saw that we had more than one input surface. And we can't have a flat list coming out because we need to set 3 points for every surface. So if we have a flat list, it would just be a bunch of points together, kind of a point soup. We want to make sure that each incoming surface has its own list of outgoing points. So it pretty much grafted it for us.
Okay.
So then going into Delaney mesh, it was able to take each list of 3 points and make a separate triangle face for each one of those lists of the 3 points. Yeah. Yeah, it already did it for us, so we didn't have to worry about adding anything into the list. So that one was pretty easy comparatively to the first one. Okay, so at this point we have 2 separate sets of meshes. We have the pyramids as one set and then the triangles as the second set. In order to get one cohesive mesh at the very end, something very smooth, we'll want to weld everything together. So we'll take all of the meshes, each triangle or each pyramid has its own set of points, and we'll want to take the ones that are overlapping and weld them together to be 1 point. So yeah, that's an easy one. Okay, there is weld mesh from Grasshopper that can do it basically, but there's a slightly improved version of welding inside of Weaverbird. So yeah, so it's a long title, but Weaverbird join meshes and weld. This will join all of our separate meshes into one mesh, and then from there it'll weld all the points together. So instead of doing a join mesh and then a weld, this just does it all for us.
Did you make that?
No, Weaverbird did. I know it's close, but
They just claim that you did.
yeah, they kind of stole it from me, so it's sad.
Really?
What? No, they just, I mean, well, Weaverbird is an actual bird, like,
Okay.
is a thing.
Oh, I didn't.
So I guess I stole that from
I
them.
I didn't know that.
Yeah,
So that makes more sense.
yeah. I don't know why oh no, I do know why they chose the name. If you ever look up a Weaverbird, they're very pretty. So we'll go on a tangent real quick. Thank you. They are kind of little architects, I would say.
They make it for their wives, something like build.
Yeah, it's like their mating ritual is just architecture. Yeah. So they construct little houses. They weave stuff together. It's kind of fun. Yeah. There's another bird though that actually makes like really complex pavilions on the ground with like colored objects. I forget what bird that is.
These are awesome.
The pavilion bird, yeah. Yeah, these are super cool. So that's what it was named after, which makes sense. Yeah. Yeah, we used Weaverbird for the necklace workflow, which I think was last week. Yeah. Well, you don't have to. The other way to do it is we could join meshes first, which is the first part of the name, join mesh, and then we can weld the meshes. So this is just 2 Grasshopper components versus 1. Yeah, let me see. Like, what's the other one that you see? You see this one? This little black one? I think this is from a plugin. Yeah, this is from Ngon. I've never used it. So, oh, if you do Control Alt and then click on a component, it'll tell you where you can find it
That's so cool.
if you ever lose it. Yeah. So, That's nice to know, yeah. Okay, so that's the other way you do it, and you could just string it together like that. So yeah, for Weaverbird, we have the mesh input, and then we have an optional weld, which by default it's false, so we'll have to switch that. But to start, we'll want to add both the mesh inputs to the mesh input so we can weld them both together. So if you remember from the past, in order to put two wires into the same input, we can hold shift at the same time. And that'll give us a little green arrow. And then we can put two wires into the same input. Okay. So once we have this, if you just plug them both in, you'll notice they're still all on separate lists. So it's not going to be able to weld things that are on separate lists. They all need to be on the same list to be welded to one object. So we'll just have to flatten that mesh input. So if you right click on the M plus and then just hit flatten, everything will go down to a flat list, and then it'll weld everything into one final mesh.
For the
Yep.
Just go into the mesh of the join.
Oh, this down here. This was just an optional workflow. If you don't have Weaverbird, you can just do it this way.
Button
I
in.
do not.
Oh, okay, cool. Yeah, so for both of them, we'll have to flatten the input. So the lists from Delaney Mesh are grafted, but if we flatten them, we take away those list denotations and they all become the same thing. So I'll do the same workflow. I can drag both outputs into mesh join, just make sure you flatten the input so it actually joins everything into one thing. If you do not have it flattened, it'll join everything in each list to itself, which is probably only one thing at a time. So yeah, you have to flatten that one. So we want to see on the result for each of them, whichever way you're doing it, but we want to see one mesh coming out. If you see one mesh, that means we've done it correctly and we've joined everything and welded everything together. Yeah, we're good, we're good. So at this point, it is very like spiky, which is maybe cool, but we're going for something a little more subtle. Let me just go ahead and turn some things off so we can see them. Okay, so this is the final thing. We can see it, but we can improve it a little bit. Well, actually, only some of us can improve it. We will need Weaverbird to smooth out the final thing, or it's just going to be these pyramids, which is fine. But you know, a little additional step, we want to make it a little bit smoother. Weaverbird has these great subdivision algorithms. The one I always use is this red one, so the Catmull-Clark subdivision. So this one we can plug in the mesh. If we look at it now, it'll be a little bit smoother, which is kind of nice. And we can actually, let me, instead of it being as transparent green, a little hard to see, I'm just going to add on a preview so we can change that. Okay, so now I can see a little better. Question?
Mine looks deadly.
Deadly?
Yeah.
Cool.
So loud.
Yeah.
Oh, yeah, so you can probably turn down some of your slider values to get those offsets to be a lot less.
3 and 0.
I think that was the last one. I think on the island.
Oh, swatch. That purple one?
The one on
Oh, Catmull-Clark? The green one? Oh, yeah, Weaverbird Catmull-Clark. Yeah.
Wait, okay,
Yeah.
so mine are still like spiky.
Yeah.
So.
Yeah, so we can preview off everything except for the Weaverbird. Yeah, like the weld to the left. So everything except that red icon. So if you do the weld, yeah, that one as well. Yeah. Yeah, because when we soften it, it's gonna go like under the sharp pyramids, so the sharp pyramids like will always be seen if we don't hide those.
Oh, so is this what it's supposed to be?
Yeah, yeah.
Why are you saying?
So if we go back to some of the domain sliders, we had those two, so that second one is probably gonna be more important, so if you make that value less than 3. See what happens. Yeah, so you can turn down that number from 5 as well. You know, start with that. Go to the right. Setting your value, so you're keep going.
Yeah.
Just wanna make sure we're setting 0. So that amplitude should be going like 3 dot.
Oh.
Probably why. So, oh yeah, that should go into the move component. So just right above you. Right to the left. Yeah, right there.
Whoa.
Okay, so yeah, now try to put the slider should do something now. Yeah. Yeah.
How does this go away? It's like, where they got it. Is this because my slider is like, is it, well, shouldn't it look like?
Yeah, so you might. Yeah, so right now you can use everything from 0 to 2.
Oh.
That first one is 0. So it's only 0, 2, 6. So that 6 will be the main slider.
Okay. Now it's like. Oh,
Okay, so if you have Weaverbird, it is soft. We can make it softer with this levels input. By default, we're doing one smoothing operation. But if you want to make it have even more polygons, we could set a higher number and smooth it even more. Yeah. I wouldn't go too high. This might be bad, but 2, 3, 4 should be fine. One more thing too, if you notice the surface, it has these little black faded edges in between the diamonds and the triangles, which isn't ideal. Something is wrong there. What we can do though, which everyone, well, I guess that has Weaverbird should have these. But the first thing we can do in between when we welded it to when we smoothed it out, we can clean up the mesh a tiny bit. Everyone that has Grasshopper should have Kangaroo, so this comes with it, but there is a component called Combine and Clean. This will clean up the mesh a little bit for us. So I'll grab that. And then to clean it even more, with Weaverbird, there is a component called Unify Face Windings. So basically making sure all the faces or any neighbor to a face is facing the same way that the faces around it are facing. I said face a lot, but like, yeah. Want to make sure everything's going the same direction. So from Kangaroo, we clean the mesh, we fix the windings, they're all going in the same direction. And now we can replace that final wire going into the Catmull Clark. And this should fix the visual bug we were seeing with the triangle to diamond shape. And now it's pretty clean. So at this point, we can play around with it some more. Again, just to label some things, this might be helpful for people too, just cleaning up your document. We have those 2 domains from earlier, which these are your main control over how the pattern is looking. The first one, I like to do this thing just so I can see like what parts I can change quickly, is I can hover over this whole set, so the two sliders and the domain. And if we select that whole thing and right click off to the side, we can group them together. So it'll basically add a little box around it. I think your boxes are purple, I forget. But mine are white. You got me. So the color might be weird, but that's not an issue. And then, oh, you have a question? I thought you were stretching.
My triangles and my mace
Uh-huh.
base are not connected.
What do you mean?
Like they're not the same match. I have to.
Like you flattened everything and then welded it?
Yep.
And out of the weld, there's separate things here, not just one.
I think so. It looks like they are. I changed the color and only the triangles changed color.
Then yeah, they are separate things. Well, and none of your wires are dotted, because that would only happen if you had dotted wires.
Maybe. But I think they would. Yeah. So what's the like this be really well?
Oh, try to preview off everything except for that final component. There might be, yeah, so I think there's a good visual here.
Why is the
Yeah.
arms?
Oh, the arms are a separate thing, which we're not gonna get to, but
I can give you the workflow because it's kind of cool. But okay, so yes, if you're able to group the things together, I'm going to do that for both of these lists or both of these sets of things. So this gives us a nice group. There's a little box around it, which is cool. But if you want it a little bit more dramatic, so you can really see that this is a thing you should change if you want to change things, we can right click on the group and it has some options. This first one that by default is box outline. We could also blob outline it, and then it'll be a lot more obvious that this is a thing that you can change, which is nice. Like from a zoomed out perspective, we can see that, okay, I can zoom in right there and start changing things. So that's good to know. We can also label these, so we could right click on the group again and say, what would I call it? We can just basically label what the sliders are doing. So the first one is kind of the attractor distance, so how far away the points were from the curve. And the second one is maybe like the pattern offset, like how much influence the pattern is getting from those distances. So with these two sets, we can play around with the sliders inside and see the pattern changing as we change these sliders. And with this first one, the include gives us some more power. So if we want to like have a trough in the middle, you could, or you could just leave it normal with the points. But yeah, maybe go the opposite direction too. Kind of interesting. But yeah, basically putting a pattern on a surface in a specific area. So say you were working on a bigger product and you had a full surface of this handle, you only wanted to put the texture on a certain position, you could just draw a curve in that area and it would do the shape in that area. If you had some reactive facade or something, you could do a very similar thing. You don't just have to use the diamonds. There's a lot of other shapes you could use. Maybe if you wanted like holes in the middle of the shape to maybe open and close based on the distance from the line. A lot you could do with something like this. All you really need is a surface and a curve to define where the pattern will show up. And you can be pretty creative with how you apply this to certain things. 6 minutes till 7 here, but the other workflow that we won't get to is just this kind of brace around an arm. A very similar process where we find the surface around the arm, and I'll zoom into the grasshopper a little bit. But using two surfaces to define the area that we create a surface. Creating that surface with a loft, basically dividing the arm into curves, lofting it together. That loft then gives us a surface, even though we started with this input mesh of an arm. And then with the Lunchbox components, we can do a pattern on top of that. And then with the dendro that we've learned in the past, we can thicken that to be a final shape that you could 3D print if you wanted to. Just a simple thing, and I can put this in the Discord after, but just a different way to apply a surface texture, just with a different kind of surface. So another little output there, but that's basically it. So any questions, I'll be here. If not, see you next week.
Hey, RJ, not really a question about like what we did today, but what was the plugin that you said would give us the icons on the images instead of the actual words?
Yeah, that's a good point. So there's a couple. One of them, I forget which one exactly I have, but there's two different ones. One of them is bifocals, which is these sunglasses here. The other one is sunglasses. And I think I'm using sunglasses. Bifocals has like you can turn it on or off with a component. Sunglasses are just always on. So yeah, download one of those. It should work pretty easily though.
Okay, thank you.
Grasshoppers.
Probably like to download it.
Yeah, bifocals is pretty old. I think sunglasses is the newer one. So I would recommend maybe just go with sunglasses then.
Thank you.
Yeah,
See ya.
Later, RJ. Thank you.
Yeah, see you, Henry. Yeah.
Do you need-
Yeah,
And then
next week. Next week. Yeah, what's up?
So my address for cash.
Yeah.
I see it.
Oh, yeah. You're trying to rebuild it?
Yeah,
Oh,
I just missed some parts.
oh, yeah, no, you got pretty far at the end. Yeah, I can leave this up.
Okay.
Yeah. Aaron, yeah.
Yeah, it's not about this.
Uh-huh.
It's not like a question on, I was like working on something, and I just wanna know if you knew. Oh, sorry. I just want to know, if you knew, like, I like had a line, and I had typing stuff, and then it came up with like this. Here because of the pipes, I didn't know if you knew like how to make it so it's just like a circle, does that make sense, or a sphere?
Like this.
So I know that you can change it so it can be flat and. Yeah, so it'll be flat, but you know how to make it just so it's a circle? Yeah.
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 I
know that's a long process.
I don't know, I'm assuming you have like an interior curve that defines all of these.
I'm pretty sure, let me make sure, so. I do, I can find it.
Yeah, it should be.
The line or,
Cause I assume like you're using a pipe to get this thing. For a suite or something.
okay, so yeah, so I have like. Oh, those, do you see those lines there? And then I like took those, and then I feel like we were just selecting. Okay, this might be the arts you're talking about. I'm sure it's.
Yeah, go ahead, move that green so you're looking at the top of
This
this
one?
one. Yeah, there
Okay,
we
so
go.
yeah, I had this mark here.
Okay. So toggle off that green zone so we're going to see everything. Yeah, so we see the curve starts and ends in those two positions. So you can grab those vertices and then set a sphere there to give you that round pattern. Yeah, so super easy. There's one component called N, I think it's just N.
Or endpoints.
Yeah, that one. So if you run the curve through there, well, yeah, we see we got this point. That's super nice. And then all you have to do is with those points, just add a sphere at both of those locations. The only question that I haven't even probably solved is like the radius of that sphere.
Okay, can I just toggle it? Or-
But yeah, you can put in any value. I don't know if it's like already defined somewhere, like how big this is,
I
but if
think it's
not,
this right here, the radius is, I'm pretty sure.
okay.
Yeah, it's like. this
Yeah,
one.
cool. So if you grab the sphere component. Yeah, so it has base and radius, a basis point, so you can drag both the start and the end. there.
Oh. And then put the radius down in.
So it's an interesting question because the radius, because the radius is even smaller circles, right? But overall, the radius is slightly bigger than that. So you could put the radius in, but you'll probably want to do it multiplied by some value to be that slight bit bigger. And then as you change the radius, if it goes through multiplication, it'll automatically. Then, yeah. You'll get
Something about her, because she's like better than most of the options for money. And then just kind of maybe play around. with
It's,
it, and then-
it's gonna be somewhere from like 1 to 2, some decimal in the I'm assuming.
Yes, yeah,
Yeah,
and then. with that. Have you heard anything from her about it? Not really.
yeah,
Okay.
so once you figure what that multiplication value is, I'm assuming when you change the radius, it'll like always dip.
Okay, so one point of that, so, okay, probably with this,
Yeah, so that's pretty good.
okay, and then add
Did you
this,
sleep
combine
some point?
these pipes.
I did,
and
I
screw it
sleep.
together.
Okay, good.
Also,
both my
Yeah,
classes.
so you can on the preview, if you wanted to like actually merge them all together.
Oh,
it's not actually dendro.
I skipped a homework assignment last night, actually, so I was like, you need to start off your research.
Not every.
Some sleep. Yeah, that's right.
Do it with geometry.
Well,
Dendro is
I will
like
see you
nice.
later. See ya. Good luck.
But you,
multiple ones.
um,
Well, could you lock these two and then just have it locked it from that to that?
Yeah.
Or no?
you could, I don't think it'd be easier though.
Okay.
Um,
Then I would do that.
Yeah, you could like, I don't know, there's a lot of older architects that are like the perfect workflows, you walk all curves together. That's
Okay,
perfect,
gotcha, okay.
But I'm like, just make shapes and then if you use Dendro for everything to a volume. And then it just combines it, it's pretty easy.
Do you know what it's called?
Yeah, so I don't like looking up, because there's
Okay.
only like 5 components, but in Dendro, we can pull that down. And basically with this first one there, yeah, we can convert meshes to a volume.
Mesh to volume.
Yeah, and we'll just have to convert your VRF to a mesh.
Oh, these.
But it might do it automatically. Yeah, so the pipes is one and then the spheres are another, so you could drag everything to that mesh. And then we'll just need some settings to actually define the volume. And we can grab that from the same list, which is that top one is great. Yeah. So before we plug it in, it's always important not to just put the settings in, but to grab a slider first. And I usually always go from 0.01 to 1. Yeah. Yep. And then it's always good to start at 1, because higher number will be, yeah, it might crash if it's.
Okay, gotcha.
So start high, that goes into voxel size, that's what you have to do, and then the settings, just go to settings. Then it'll convert everything to
cool.
Dendro stuff. So if you preview off all of the stuff we have up,
You know everything?
yeah, we don't need to see any of it, we'll just get away. And then scroll back down there, and then if we grab in inter, whatever that one is, grab a union, and that'll actually union the binary together. It'll be important though to flatten the list that's coming in.
In here.
Just the union, because if it's not flat, it'll not reflect it like together.
Actually,
That's
okay.
cool. Now it's together, so now all we have to do is turn that slider down,
Yeah.
so we get to some resolution that we like, and you can see the detail of it.
Well, that's cool.
Yeah.
Yeah, flash it, but okay, that's.
Yeah, so now it's easily one mesh, and then, yeah, we'll probably just have to turn on, turn off.
Oh, this one.
stuff. Yeah,
Okay, cool.
Yeah.
That was so much better, thank
yeah,
you.
this would be really fun stuff.
So, yeah, so Dendro's in here.
Yeah, it's usually all you
Mesh
do is
to
like,
volume.
mesh to volume, add some
Take the two
settings.
meshes and combine them. Okay, cool, thank
Yeah,
you.
yeah, that works for any meshes, so.
Perfect, all right, thank you.
Yeah, well, oh, yeah, yeah. Test package manager. What if you hit install? Oh, it was. So it says that it's in here. Yeah. Like this one. Yeah, and then like I installed it, it doesn't work, and it didn't update, not updated, and then, you know, application. I go back in and pull out this at one time, wasn't it? Yeah, no, it's weird. And it is running 6. Swear to God. So I mean. There was originally one, yeah, but yeah, and I started doing it the way they did. So, yeah, yeah, and you know, because originally we didn't remember that first error I showed you, but now it's not gonna. Wow. Um, yeah, I'm not, it's a weird one, because it doesn't have that zip file. Let me see if I have like an older version of it on my computer. Might help.
How often are you using, like, if I don't have it?
I don't think we'll touch it again.
It seems like a cool one for like architects to have.
Yeah, because it's got like trusses and systems that you can just pull into things pretty easily, which is nice. It's kind of a weird one. Yeah, structure is good, panels are cool. The machine learning takes another whole thing. But let's see.